So now that we've talked about standard deviation, let's take a look at how we would do this more by hand, and then also I'll show you how you can do it on your calculator. So example 2 says the GPAs of a sample of 10 non-honors students and 10 honors college students were obtained for a study and are given below. So we're going to find the sample variance and standard deviation for both the non-honor students and the honor students. So I may underline, right, sample variance and standard deviation, but the biggest thing, right, is it's from a sample. So we're going to be using the formula for sample standard deviation for the non-honor students. So I'm first going to write, you will notice the very first column says X values. So that's going to be the actual pieces of data for my non-honor students. So I'm going to write all of my values here. They don't have to be in order since we'll calculate it by hand. Even in the calculator, it doesn't really matter, just as long as we make sure to include all of the values there. So that's my first step. And then we'll look at what we sort of need. So my second column says take the piece of data minus the sample mean. And then the last column says take that deviation, right, x minus x bar, and square that. So the first thing I really need to do is I need to find the sample mean. So it's the sum of all my x values divided by n, where n is the number of pieces of data. So in this case, right, we said there were 10 students. And so I need to go through and I need to add up all of the values that I see here. So let's do that together. 3.8, 1.55. So we just want to get a total so that way I can go through and find what my sample mean is. And so let's see, 3, you don't have to write the decimals when it's the 0, 76 plus 3.26 plus 2.14 plus 2 plus 2.71. All right, so I end up with 26.35. And that'll divide nicely, right, by 10. So I end up with 2.635. 2.635. Okay, so since we're calculating it by hand, the more decimals we have, the more decimals we will have when we square it. So I'm actually going to round this just to 2 decimal places. So that way it's a little bit more manageable to do by hand. All right, so my next step is to go through and actually fill in that second column here. So I'm going to take 3.8 minus 2.64. I'll find those deviations. So 3.8 minus 2.64. It can be positive or negative. If it's positive, it just means it's above the mean. If it's negative, it means it's below the mean. So I found that difference there, and then I'm going to square it. So I'm going to hit my square button, and I'm going to keep all my decimals here. So 1.3456, okay? So now I just want to go through this process and do it for each of the pieces of data I have. So I'll take 1.55 minus 2.64. So 1.55 minus 2.64. Right? Find that difference there. This is now below the mean, so we'll end up with a negative value. If I square a negative, though, it should be positive. So 1.1881. And so let's go through. So 2.24 minus 2.64. And I'll write that deviation down, negative 0.4. I will square that to get 0.16. And so we're just going to do this again for each of the different pieces of data that I have so we can find the deviation squared. 0.25, square that. 0.625. Again, we're not going to round until the very end, so we want to keep all those decimal places. 2.64. Write that down, 0.36. I will square that. So 0.1296, 2.76 minus 2.64, 0.12, and I square that. So as you can see, this can be a very tedious process. this, right? And there's lots of areas, right? Lots of places you could make a mistake, right? If you type in the wrong number, if you write the wrong number from the calculator. And so I like to show you this by hand sort of the one time so you can understand the process. But a lot of times we actually go through and we'll use maybe a calculator. You could use, Excel or some type of statistical program to enter the data and then have it calculate this for you. It's much faster just to enter the data and then ask for the standard deviation. 2.64, and then I'll square that. So negative 0.5 and then 0.25. Need just a couple more. 2 minus 2.64, and then square that. So negative 0.64, 0.4096, and then my last one, 2.71 minus 2.64, and I'll square that. So 0.07, 0.07, sorry, this one was negative 0.64. My eraser got that. So 0.0049. Okay, so I filled in all of my columns. The goal then is I need to add this last column all together, okay? So what I mean is I'm going to take all of these pieces here, I'm going to add them all up to see what I end up with. So I'm going to add these all up. And so after I add them up, this is going to be my numerator for my variance and standard deviation. So let's go through, let's go ahead and add these all up. 1.3456 plus 1.1881 plus 0.16 plus 0.0625 plus 0.1296 plus 0.0144 plus 0.3844 plus 0.25 plus 0.4096 plus 0.0049. All right. We will enter, see what we get. So we end up with 3.9491. Okay. So that is my numerator for my variance and standard deviation. So let's again write out. So for my variance, my formula, so s squared is equal to the sum of my deviation squared divided by n minus 1. So I found the numerator, 3.9491, and I'm going to divide it by the number of pieces of data minus 1. So 10 minus 1. So 3.9491 divided by 9. So I have 3.9491 divided by 9. And so if I round this to 2 decimal places, right, roughly 0.44. Right? And GPA does not have a unit attached, but if we saw a unit, the unit would be squared for variance. For standard deviation, it's really similar. The only difference is it's the square root. So the sum of the deviation squared divided by n minus 1, and we're going to take the square root of that. So I have, again, 3.9491 divided by 10 minus 1, and I'm going to take the square root of this thing. Now, you may realize that that answer there, right, is this 0.4387, right, 88, ... We do want to take the square root of this non-rounded answer. If we take the square root of 0.44, there may be a rounding issue. So let's go ahead and take the square root, second x squared, and then second answer, and it'll take the square root of that answer that we have, roughly 0.66 for my standard deviation, okay? So that's what I mean to sort of do it by hand. So let's go through, let's do the same question again using the same data, but we're going to go through and do this in our calculator, okay? So we're going to go, remember, in order to enter any data, we're going to hit our stat button, go into edit, and then we're going to enter the data into L1. So let's go through and again, enter the non-honors data. into my calculator. 2.9, 3, 7, 6, 3.26, 2.14, 2, and 2.71. Okay, so I have all my data there. We're going to go then to stat. Over to calculate, we want the 1 bar statistics. So we just want L1. If you have the older version, you'll just hit enter, and it will calculate for us. And so we found, right, the sample mean, which we found. We have the standard deviation for both the sample and the population. So the calculator will always give you both. You have to decide which one you want. And so if you notice, we want the sample, right, which is 0.66, which is the one we found down here. You'll notice it does not tell you what the variance is. So what you're going to do is you would write this whole number down, and then you would square that in your calculator, and that would tell you what your variance is, okay? So just word of caution, you do have to go through and square the standard deviation in order to get to your variance. All right, so now we're ready to calculate the honor students' standard deviation and variance. So we're going to go back into our stat button, and let me turn the page, right? So on the next page, it says using the calculator for honor students. I'm going to go back to the previous page just so I have the data. So I'll hit my stat button, go into edit. We want to clear that list out, so arrow up to L1, hit clear, and enter. And now we're going to enter in my pieces of data for the honor students. 3.95, 4, 3.91, 3.89, 3.94, 3.84, and 4. Okay. So then I'm going to go again back to stats, arrow over to calc, my 1 bars, scroll through. I want to calculate that. And so again, it tells me the mean, which I don't really need in this case. What I do need is the standard deviation. So I'm going to go to the next page. So I'm going to write what that standard deviation is, 0.0594418. 483. Okay. So I have my standard deviation. So S would be roughly 0.06. And then what I want to do is I'm going to take this whole number here and square it. So 0.0594418,483. And I'm going to square that. And that's going to tell me my variance. So 0.00, roughly 4, okay? Now the last piece of this question asks for an interpretation. So we're going to look at our standard deviations, right? So my standard deviation for the honor students is 0.06, which is fairly small. My standard deviation for the non-honor students was 0.66. So if I think of interpretation, we would say that the GPA for the honor students are more consistent, right? They're closer clustered together. As with the non-honors, there is more spread, right? They're more spread out. Now, if we had the mean, we could then also talk about what's happening at the center. But if we're just looking at the standard deviation, the larger the standard deviation, the more spread out the data is going to be.